Okay, I guess I'll get started. This is Mark App from the Great Lakes Data Watershed, founder of the Great Lakes Data Watershed. And this is the second in our series of workshops showing how you can access and process public environmental data. And today we'll be focusing on the processing part of that. So to give you a background again, if you weren't on the first call, is that this work all started as part of the Lake Erie hack in 2019, and we more and more have kind of gone into an area where we're really trying to help others share their environmental data and make better use of it. So related to that, we have our challenge that we're supporting, and is that we believe there's a lot of good water quality data out there, but the number of the access to it is somewhat difficult, and the number of resources, web resources that really give you the ability to interact with it, to explore with it, and to work with it are very limited. So you can look at our hack there. There's another hack that's been put out by Toledo, the city of Toledo, related to a dashboard, which we will also support because they're so related. Now, so the support we're providing as part of this hack is that we'll help to mentor up to 3 teams. We'll conduct these workshops about getting data, and we'll have support sessions. So if something isn't answered here, I mean, we don't know everything, but we can kind of help guide you as to how to construct access to whatever data you're trying to get to if it's not available easily. Ongoing, and I didn't make this clear last time, is that we're going to be around and we're going to be hosting dashboards. So if you create a dashboard of public interest, we'll host it, and we'll continue to have ongoing workshops and training. So I'm not going to go over this again very much, but recall that an API is something that allows 2 computers to talk to each other. And the way that we usually do that with web applications is to use something called a REST API. And then we talked about, if you look at the slides from the previous presentation, it goes into much more detail about that. And this is a repeat that, why would you want an API? Because you want to display data, you want to plot it, you want to map it, you want to get the real data from the source right now. And you might want to do some kind of automated analysis of it where you need to grab it, or you might want to monitor parameter and alerts. So there's a lot of reasons you might want to get this live data in addition to building a dashboard. So again, this is a repeat. It was talking about what a REST API is, and it is very commonly used over the web. Most all the public sources that we're aware of use REST APIs. There used to be something called web services that are a lot more complicated, and some of them still support that, I would imagine. And a key thing is when you get data back, and that's what the subject of this presentation is about. What do you do once you get the data from them? So what kind of approach can you use to process the data that comes back from a REST API? And that's what we're going to be digging into. So, and recall that REST APIs can return data in different formats. Fixed being data that's kind of, you have to know where the position of something starts and ends. And it's kind of a little hard to figure out where, say, Washington Creek, if you were looking at this example, where that word starts. So, but fixed is a format you run into. And delimited is a kind of format where it has some kind of character that separates the different fields. So in this case, down here from the USGS, we have data that's delimited by commas. And so it's not too hard to process that, but you don't really know what each one is. And so it's kind of, it's not that trivial to kind of set up processing of that. In our case, we're focusing, and this is where we'll go with the rest of this, we're focusing on what's called structured return data, and specifically JSON. So JSON has a particular structure that is very predictable I mean, you can figure out what everything is just from reading it. It's self-descriptive. And XML was commonly used before, but a little less so now. So XML was used by the older style web services, SOAP web services, and it's still available. So you can still get XML if you prefer from some USGS APIs. But I guess I would recommend everybody move to JSON now. So we're catching up from what we did the first thing. And again, this has been recorded and you can review that online. It's in the hack, where the hack has put those recordings. And now we're going to get into the new stuff here. So any questions at this point? Okay, well, I already alluded to the fact that I think the best approach is REST APIs using JSON. Now, the question for that, why REST APIs are so good? Well, they're kind of simple. A bad thing about them is that they can be, not everybody does them the same way. So you can't count on a REST API behaving the same from USGS or from NDVC or from any other source, from different types of instrument vendors. Why JSON though? If we accept that we're going to use REST APIs, well, the reason we use JSON is because it's becoming the universal standard, I think, to some extent for returning data. It's most sources that we're interested in allow you the option of returning JSON, and so you can start to deal with only the same kind of structured data all the time. With JSON data, you don't always need to have metadata to figure out what it's doing. So, you don't, and we talked about that in the first workshop. So if you go back and look at the first workshop, we talk about what problems security and metadata can cause in making it easy to get this data. And so in this case, we're saying if somebody designs their JSON format data in the right way, you don't need additional metadata to start working with it. And this isn't a complete list, but JSON is very well supported in most programming languages, including the more common ones like Python, R as if you call it a programming language or scripting language, Java to some extent, and of course JavaScript, since JSON was designed to work with JavaScript, so it works with JavaScript objects. So it was implemented there initially. So no matter what language you use, probably JSON is something you can work with. So I'm going to stop here and give you a chance to take a look at a few things. And I picked a couple APIs to look at. I'll put these in the chat. I remember yesterday I had trouble finding the chat, but let's see here. I'm much more used to using WebEx, so that's mine. One second. So the reason I'm putting these in here is I'd like you to, to do those and kind of look at the data that's coming back. And that's JSON. So, when you look at that, it kind of seems pretty apparent what JSON is. But you should go ahead and do that and take a look at the return data and kind of now both of these APIs would be appropriate for building a map. So the question is, do we have all the information you need in this data to create a map? I'm going to put it up here. So the question is, do we have all the data we need to create a map? I'm going to wait a second and we'll look at this data. Make it a little bigger. And the problem with the first API is it doesn't prettify the JSON, so it's a little harder to look at. It has very similar data and could be used to make a map with the data. But yeah, I'm using this one because it's formatted. It's more easy to ascertain the format. So I'm asked the question: does anybody want to unmute and just say, okay, looking at this data, do you have everything to do a map?
It looks like it. What is there like an easy, what's the easiest way to create a map? Like take this data and put it on a visualization of some kind.
Well, in R, there's some really easy stuff to do with the map, and I have sample code in R. In JavaScript, you need to have a mapping library, and I've been working with one called Rickshaw, and we have built a layer of code over it that kind of makes it real easy, but it's a little more difficult. But if you do this in R, it's almost trivial. You just have to map these to certain arrays and then call the mapping thing. And it's pretty much the same in JavaScript. So, but if we look at the data values here, we can say, okay, well, we have a latitude and longitude, obviously need that. You probably want a date of some time. Now, Chad, since you're the one that's, we have two different formats of date, and you know, you need to, if you're going to plot something, you probably want to put the date on it. So do you see both of these? Which do you think would be easier to work with?
Well, the first one didn't load for me. I'll try it again here. So
try the second one. Maybe I have the wrong URL for the first one, but
I'm on yours right now, the second one.
Yeah. I don't know if I believe that had an event time like this one right here. It had a formatted date. And this one has a timestamp and a formatted date.
I think if I end up, I'm probably just going to focus on yours, and I want to figure out how to put it on a map and then create like a simple UI thing where it just shows like the flow on each location, and maybe like a toggle to change it from the flow to maybe just flow for now, and then I can expand it later. But I think my concept is kind of related to the flow. So if I can map out the flow, I think I'd be happy.
Yeah, yeah. Well, I actually actually we're putting together a map where you can pick the. Well, I'll show you a couple things on that.
Okay.
But you can either use, if you now the decision you have to make is, do you go JavaScript or, I mean, there's many ways to do it, but what technical approach do you take? Yeah, go ahead.
I know a little bit of JavaScript, so, and I know no R whatsoever, so I'd probably go JavaScript.
Yeah, yeah. Well, in this case, we have sample code we can give you that has most of what you need to do, and you can kind of like tailor it. We don't have exactly with our APIs. Now, there's nothing wrong with the WaterWatch APIs give you data that you can put on a map too, because it has, you know, you need a latitude, longitude. You probably want the date in some format. You probably want the individual parameters spelled out. And you probably need something to label that pin with. So in this case, this is the, you know, the Rocky River tributary or whatever. So, and conveniently, we add, and so does WaterWatch, they add a link back to the original data. So it's really nice is if you create a map with that, you can say, oh, you want to go click back to USGS, you can go look at it also. So, and there's some stuff you can do with the hydrologic unit code too, which is here. So, we can talk about that more.
Is that timestamp in Zulu?
What's that?
The timestamp is in Zulu. You don't have the Z missing from the event time.
It's the the old Java time that starts January or December 30th.
Right. I mean, so that's the Unix timestamp. And
Right.
But the thing is that if you want to say event time, you should have Z or something at the end to indicate that particular date time is in Zulu. So without that, that's not a sufficient specification. If people can assume that if it's left out, it's in UTC, but it's better to put a Z at the end to specify it's in Zulu rather than leave it alone, because you can have that timestamp -8, and so that event time, that string can be specified in multiple ways. But without the definition of which time zone it is that is in UTC, that's not a complete specification.
Yeah, most of the date specifications have the have indicated what time zone it is.
Right, but so I think to the extent your data set is global, and if it's in the UTC, then you should really have a Z at the end of the time string.
I'll take that under consideration. Yeah, this is basically it is UTC, and but it wouldn't and we're using it with the intention it would be UTC. I've not seen timestamps because they're usually stored as integers with the Z on them.
No, not in the timestamp, in the event time string.
Oh yeah. That's what came from the. Yeah, I agree with you there. Okay. Yeah, the ISO format would probably include the Z. And in this case, yeah, that wouldn't hurt. Okay. Did you have any questions or thoughts? Anything else you wanted to share?
Yeah, the thing is that clearly you gave the URL there, and I can see the URL here. But and then the flow-based thing. But if I more interested in this particular URLs, I don't know if there's a README that says this is a URL and these are the parameters you send to it to get the response back.
So you're suggesting there's not, the documentation is an issue, or what are you saying?
Right. So I can see these pieces here, but I don't get a full sense for if I want event that were a week ago. So the start time, end time, how would I get those events rather than?
I'll share that with you now, okay?
Yeah.
I got it. All right. So again, I'm trying to remain somewhat I'm trying to leave this open so you can use whatever APIs you want. All right.
Yeah.
We have a set of APIs that we think are really easy to use and well designed, and I want to share where the link is to the documentation on them.
Okay.
So if you go here, and then you go to About.
Yeah.
Then you click here. Here's the API guide.
Okay.
All right. And these are some of the sources of data that we have.
Yeah.
So if you go to the API guide, this is pretty new, but it's all pretty good.
Yeah.
It talks about all the different APIs, including the ones that would let you know what data sets are there. So one of the problems is, the one there you can get retrieve metrics or retrieve events, you can specify a from and to date. So I'm obviously not looking at all these. And again, if you look at the USGS, and these are GLDW, right? But if you look at USGS, there's usually an API that's good for mapping and one that's not as good for mapping. So this one is great for mapping because it returns every event, latest event. So if you want to map every bit of data in GLDW or whatever data repository you have, you can use that one.
Yeah.
If you want to retrieve a specific metric and plot it,
now, what is the core definition of an event? How do you define an event?
An event is something, I mean, this is so, I'm using the standard kind of computer view of that. So, and, you know, in computer systems, they talk about streaming events. And events is something, I'm making this up now, so I probably should, but in my impression, it's something that has a very specific time that occurred, and there's some data associated with it. So in that case, every metric that we have, you know, that we read can be considered an event. And
right. So what I was getting to is the granularity of the event is different between different API. USGS flow data might be at 5-minute interval, and they're also not necessarily time synchronized exactly.
Absolutely
on
right. You're absolutely right, and that's a big problem. And one of the unique things that we do at GLDW, which really makes it extremely more useful, is this API, the one that's kind of off the page.
Yeah.
It's called Aggregate Events.
Yeah.
So you can give it two totally disparate events. So you could give it like a flow and a river in Ohio, and you can give it a buoy data, or you can give it the phosphate data in the Maumee River and give it some buoy data. And you can specify two data sets, and it'll bring them back and aggregate them. And it will handle the issues of data alignment pretty well.
Yeah.
So you're right, data can come in at different intervals. It could come in every hour. It could come in every 10 minutes. And that's a real problem when you're trying to aggregate events. And I think we're the only ones doing this well, by the way. And it is something we just started doing, but it allows you to do very sophisticated. It allows us, I'll show you one thing. I'm going to jump back to the slides. I'm almost done, and I'd love to talk about all this, but I want to make sure we're staying on topic. I'm going to show you one here that we use that aggregate event, since you're familiar with the issue. And this is one where we go and we have all the data from every possible station, Great Lakes, USGS station around in the Great Lakes watershed. And you can click on it, and it actually goes and does a comparison of the stage and flow from that in a scatter plot, which is really good for trying to figure out correlations.
Sure.
So we can actually do that for any two metrics in the database by using that aggregation API. So I don't think anybody else is doing it. We're not trying to explain it to people now because it's kind of complex, right?
Yeah.
But the point is that we have an API.
Yeah, what we call the engineers a rating curve.
What's that?
We call it the rating curve.
Oh, okay. Yeah.
So that's fundamental of hydrology for civil engineers, what you drew there.
Yeah, and that's why I think I was playing around with it. I mean, I'm a chemist, not a hydrologist, but I kind of get what the different slopes would mean here. So it's been fun working with that. Anyway, we're getting off on a sidetrack, fun one. But the point is that, there's very sophisticated APIs in GLDW, and they're all the ones you need, and they're easy to use. I'm not trying to push them because I don't think I should be pushing what we're doing only. We're trying to help you, get whatever data you want. But let's continue.
Okay.
And I'd be happy to meet with either, anybody on a more, and if you want to discuss more issues. But anyway, let's look at those. So we looked at these and realized, okay, do we have all the information that we need for this to create a map? And I think the answer is yes. Let's look at the next one, which kind of gets into the JSON, into another one. So this is a GLDW API, only because I knew how that worked. And if we put that one in there, and I'll put it in the chat if I can find it. Here it is. We have some more questions. And again, this is to look at, the whole purpose of this is let's look at JSON. Does that one work for you, Chad?
Yep, that's good.
Okay. So here's the questions. Does this data have all the information you need to create a plot? And a lot of the other sources of data do, but you might need to use other metadata, but I just knew mine, so I threw this up here. What would be difficult to do? And what other information would you like to put on the plot if you had it? So let's look at this, this data coming back. It's the same data, by the way. And we call it event data. So what would be, did I click? Yeah. So this is data coming back from a single station. This happens to be the one in Rocky River, I believe. And it's got, if you look at the event data now, these are all different times, right? They're an hour apart, the timestamp. So you don't really need the latitude and longitude because you're just plotting it. But what do you think what do you think would be hard to do, and what do you think would be nice to have in the data that we don't have for anybody?
So one of the things that's going on here is the units are missing, right?
That's correct.
And so that's a biggie because
Correct.
and in fact the units are there. It's easier to take the units themselves and put it on the plot without trying to do our own conversions, and we are fidelity to the data. So that's a biggie.
Yeah, but
it gets to saying, do we want to increase the size of the JSON by including it every time, or including the metadata? And so some difficult questions. If the payload is small, then including the units there is actually not a bad thing.
Yeah, and we have there's ways you can build data return that includes the units when we know them. So we're not in GLDW, but you're right. It would be nice to know the units. It would be nice to know what you should put on the title. Maybe it's this, if somebody knows what the station is, the date, time, which either of you, which do you think you'd want to work with if you were trying to, and obviously if there's no Z on the end of this, you wouldn't want to work with it, I guess, but what, would you comment on which of the times would probably be easier to work with?
The lower one?
Yeah, and in fact, in most cases, we're using the timestamp, but because you don't have to do double conversion. You don't have to.
It may be easier to work in smaller instances, but in terms of global standardization and IoT data, and everything is going to the Unix timestamp because there are no questions asked about what time was it as you get data from different time zones. So we standardize our time series storage in terms of the Unix timestamp. And then we convert it to whatever zone we want, because it doesn't really take that long to convert it from the Unix timestamp. It's really 2 lines of code that converts it.
That's what we've tended to do also, because it just, that it just seems to be simpler, and it's available, always available.
Yeah.
So, the standardization of formats. Now, one of the issues you run into, and this is why, is you don't have the timestamp. If you go to USGS or NDBC, usually the data is in some kind of format like this, the date, time. And it takes a little, we usually spend an hour or two trying to figure out how to make sure we convert that properly. So that is not trivial usually. And usually in some cases they use a good ISO format, maybe you don't need to do it. And the thing is, JavaScript is not very good at that. Java's much better, in my experience.
But so, the issue, then Chad may also want to know about it, is the browsers and local systems and computers like to do their own conversion on time and automatically convert to the local time, regardless of how it's sent from the system. And so that plays into how the local time displays in your browser and what they want to do with it. And so that's another level of complexity that comes in, that the browser wants to do its own thing with the time that you're given it.
So the timestamp is like a universal one, but the lower one is like a local timestamp.
Well,
yeah, or the browser would do its own thing. So Chad, you may want to be careful as you get those timestamps. If you put it in the browser, it may assume it's a local time, where it may be, some other time. And so therefore having the Unix timestamp and then the using other conversion for doing that, that'll work best for you.
Yeah,
Okay.
it can be a real, it's really something you usually have to scratch your head about a little bit and think through it. And if you do use the Unix timestamp, at least you're eliminating one level of problems, probably, but you probably might have others. You know, we have, but anyway, it's certainly something that takes time, even if you have APIs that get you all the data you need. You're absolutely right about what typically you'd want on here is units. You'd probably want Exis labels and stuff like that. One thing I'll show you is that in BDEV, we have the ability, in our technology, we have the ability to build a flow or something that actually returns an API, a data set with more information. I wonder if I can remember. Just one second. Now it's not automatic, so you kind of have to build this thing. Let's see if it works. Oh, okay, here you go. So you see this return? So in our product, you can build an API that has got enhanced data and you can customize what's in it. And so in this case, we built this, there's a little bit of a program we built. It's in a flow, it's a visual program that includes where it has it, the unit information. Now we encoded it this way, which is not, I don't think, ideal. But, you know, we have mechanism. The API I showed you before works for every bit of data perfectly. But if you wanted to customize an API, and we can do this if you have a particular need in your hack, we can throw one of these together that gives you more information about it.
Just a quick question. What is a percentile a measurement of?
Well, in this case, I believe it's the stage. So staging, no,
Stage,
no, it's percentile. It's percentile. So with the WaterWatch data, the WaterWatch data has historical information, and it tells you back how high this is relative to all other days of the year. So it comes back with a 90%. That means that it's higher than it's been 90% of the time. And the units of that would be a percent. So in the case of the staging, which is the height, speed, and it's percentile. So actually, Chad, you might want to you may use one of these custom APIs, and we'll throw one together for you if you want to use the GLD platform.
Okay.
All right.
So the percentile in this case is referring to stage, but could also apply to flow. So you want to make it clear as to which particular measurement that percentile applies to, Mark.
Yeah, and this is what USGS is giving us. So I think, you know, we could go look and say this percentile they're giving us. Now we're not calculating it. So I think it is on the flow, I would imagine. But yeah, you know,
and so, but because you have the source there, it's up to the user to go look it up, and then, you know, so
all of our maps let you link to the source of the data, so they can go there and get more information.
The other thing I want to make you aware, Mark, is the lat long passing it that way is no longer a standard. There are other ways that have come in, especially Microsoft has something called coordinates, and it's a nested JSON. And in the coordinates, then you have lat longs. And so I'm not suggesting you change over, but just making you aware that different standards are evolving that are using nested JSON now, like lat long is sent in as a header coordinate and then lat and the long. And obviously that makes a extreme hardship for parsing anything uniformly, but that's happening.
Yeah, and that's why we avoid the existing standards sometimes, because you just can't get it done. I mean, we're a small team and we've done a lot. And I think if you try to stay with every standard, I mean, I've been a product manager in the Silicon Valley for 15 years. And when we designed products, we had to realize, okay, how much should we embrace the standards and how much should we stay away from them? And you really can't embrace them entirely or you'll never build it. but you have to make that decision. You have to be aware of the standards that are out there so you're not conflicting with them. But, we couldn't possibly look at every standard that's out there for IoT data and or environmental data and remain sane. Let me continue and finish, and then we can have any conversation would make sense. I'm going to go to the next slide. So the big question is, so we said before, what are your options for accessing data? And we'll help you in any case, but you build data access directly. Some of the sources are pretty reasonably easy to work with, but you do have some security and metadata issues usually. If we have a GLDW adapter, you can use our data. And if we're not pulling it every day right now, we will. But right now we're getting a lot of USGS data. We're not getting, for example, I'm not storing the phosphate data from USGS stations on the Maumee River right now. But if somebody needs that, we can start pulling it. We're interested in getting adapters for everything that's useful. So if you have one that you'd like to do, we have a limited bandwidth. But if you have one that you want to get data from, and you would prefer to work with the GLDW format and APIs, if we have time to fit it in, we can work on the construction of that adapter. Like right now, I talked to the people at Gloss. Are you both familiar with Gloss?
Yeah.
Okay, well, Gloss, I've got their API information and I'm creating an adapter for it. So we're working on that right now. And so all the data that's in Gloss, we should have access to. Theirs is it's alpha or preliminary, so we're not publishing that, but we're working on data adapters for that. So, but regarding our company and the GLDW, we'll be happy to coach you on any of these. And coaching means whatever time we can to help you, but we have limited bandwidth, and so, but we don't feel bad about reaching out. If there's not enough, if we don't have enough time to help, we won't, but we'll do the best we can. So here we get to the big decision, and the question is, how do you want to build a dashboard, or how would you want to build a web screen that uses this data? And I think from our standpoint, we recommend two options. One is HTML and JavaScript, and the other is R. If you're a data scientist and you've already used R, that's perfect. If you've done more web stuff, then that's better, probably. Both can work quite well. There are other options. Probably, can either of you name other options? I think that
Python would be another option.
Yeah, and
I thought R was Python.
What? No.
No.
Completely different. Similar in the syntax, but Python has much stronger footprint in terms of applications in AI, machine learning, and R had been traditionally very strong in statistical based things. And Microsoft bought R people and trying to put more life into it. And so in medicine and all that, R is more popularly used, where the new upcoming word in ML, Python is a much stronger thing. And then Python has a lot more machine learning packages than R. But R, are you saying R desktop, or are you saying website, or what are you saying, Mark, here?
R Shiny. So you write the R and then it's hosted on a web server.
Okay. And then the third option I would actually suggest is split. So your API is essentially a backend data says an API server, but you can actually put the business logic of what you want to do with your data into a server, and then have any kind of front end you want, whether HTML, JavaScript that reacts to it, or C# or ASP.NET. And if you decouple that way, then you can write the code for consuming your API virtually in any language, C++, C#, put that in a central, what we would call the app server. So yours is the API server, then there's an app server in the center that brings the data, which then automatically, depending on the model, you use the model view controller updates the UI automatically, or a variety of ways they can do that. So
Yeah.
I mean, I see a variety of ways of consuming your API. The way you've written it, I think, can be consumed in virtually anything.
Yeah, I think in general, we're suggesting here you already have data you can use for the API and you don't need an application layer. And I don't really want to get into that. I was a technical architect designing these layers for 15 years, but I think that gets beyond what one really needs to dig into to really do good web pages and stuff. So I'm suggesting we stick with two layers, one that's is serving up the data, which we're assuming is someone else, not you, and where you're displaying it, have interactions with it, and that kind of thing. So we'll be happy to coach you with either of these methods. There doesn't mean that there's not other methods, and it's just that we're not. We have expertise in these two things. We've done Python. We dabbled in all of this. But I think if we can really give you a clear direction on these, and I think these are really pretty good approaches. As you pointed out, I think Python is an up and coming thing. And I think if I was a data scientist, I'd probably lean toward, using Python as opposed to R because I'm a programmer. But, I think that there's good arguments for all the tools, and Python is certainly a strong and up and coming. So last two slides, and then we could just open it up for questions or when we're done. So I will have, if anybody needs sample code for using this in either type, we'll send it along. I think, we're going, the way we code stuff, I mean, if somebody's actually a perfectionist in that particular language, they might say there's a different way to do that, but we get it to work and it's pretty efficient. So basically, this shows you code in JavaScript that would go and get the data, USGS data for this station and retrieve the events. And this is really the meat of it. This is how you do an HTTP request in JavaScript. And the key thing is when it comes back is you parse it and then you do something with it. Now, I'm not showing what you do with it, but if you call our API and a lot of other people's APIs, and this builds the URL that you're going to call, and you call a GET request to it or an HTTP request, it's going to return the data. And the first thing you might want to do is take the data and convert it into a data structure. And that's this API. This is the JavaScript. This is the magic glue that takes JSON and converts it to the language structure. And so if anybody needs sample code for how to do this, and including plotting and stuff like that, a lot of the plotting we do is based on our libraries. So if you don't want to use our libraries, I would consider open source. Not everything we have we consider open source, but if you want to use the stuff we used to plot with Rickshaw graphics, which is, I believe, is based on, I forget what it's based on, D3, is that something? Anyway, if you want to use our libraries so you can make a plot in a minute, I mean, you can literally, Chad or anybody else, you can make a plot that plots in 1 minute. If you want to get started, you can use our libraries. You can do that in R too, either way. The thing is, you're using our libraries, and we don't want to lock you in, but if you want to write in the plotting, you want to do all the work we did on the plotting code, that could be thing. The thing is, if you're going to do something really cool, you probably are going to want to do a little wrinkle on it. So, but we can compile that. And the next, I'll talk to Felicia, but the next workshop we have would be probably the output of that would be to say, okay, here's some code. I will give it to you. You start out kind of a lab and you do a plot of this and a plot of that, and a map. We'll give you the map code too, and it gets you started there. You get your hands dirty, right? There's two routes again. There's JavaScript, which right now, if you want it to be really easy, you'd probably need our libraries. but R is another option, and it's, you know, equally easy. And, you know, all the libraries are kind of standard out there for our users. And basically they have the same kind of thing, is that you go and create the URL. In this case, you just call a function called from JSON with the URL, and it returns an object here that has all the data in a nice structure. So I thought this is pretty cool. And their function that converts to a local object is called from JSON. And again, by the next meeting, we'll have a link to sample code to do most of this. You know, there's sample code here. This does a plot, then there's 2 more lines to do a plot. You know, there's not much additionally. So, you know, so the basis of doing a plot in a map in both R and HTML JavaScript is not that many lines of code. Again, if you're using HTML JavaScript, you need to use existing libraries probably. And there may be others. There's all kinds of sets of libraries. Anyway, I think that's pretty much what I wanted to cover today. Next time we'll get more into actually getting out sample code and stuff like that. Are there any questions?
In the data, back when we were talking about percentile, you said the percentile it's based on the flow, but it's the historical flow. So if it was 50, then it's 50% higher than it was that day last year.
Yeah, let me show you something, because in some of one of the purposes of our dashboards is to try and be educational. And if you look at this one, it kind of describes that. Now, I think being a hydrologist, one would have to question, you know, I'm not sure whether it's based on the stage and flow or flow. You know, they're pretty similar, but the point is, let me look at which one is this. Oh, here. This is a dashboard we built for the Cuyahoga River that shows the flow at different times. And you can go back and, you know, on the different entry points on the Cuyahoga River for paddlers. But in all of our dashboards, we have some information regarding what the different things, you know, we try to provide some educational information. So this talks, you know, these are definitions I've taken from USGS, but in reality, they're not. It says flow here, so I think I got those words from them. And I explained it rather simply, but the percentile is the percentage of time that the river flow is lower. So at least I think I got that from USGS. So I think that it would have been the flow, not the stage or the height, the depth of the river.
Okay.
Any other questions? Comments and anything else?
How far do you go back?
In this case, it depends on the data set. Some go back 2 years.
Okay.
But you know, we have a server in it, and if you're familiar with systems, look at the performance here. You know, we're going back 2 years, and look how fast it's doing an individual query for each of those. So we have a pretty. It's not just repainting the page; it's actually going out and refetching the data. So we're based on a Mongo database backend, which is really high performance. Now, is it high performance without tuning? No, because it can get to the point of running out of memory and stuff like that. But we have the core of a real high performance system. We have data going back a year for some things, and 2 years for some things, not for everything. And in fact, one of the other, and we might not, like the phosphate data, I don't have that right now. We can start, you know, we can set up things that capture it all. But if you look at these hi-fi stations, which they're new stations that are coming in, I believe this data only goes back a month or so, because that's when we started to get it. anyway, any other questions?
And then I guess that's in your website and somebody wants to start pumping some data into your system, like, you know, something else that's Hi-Fi is doing or whatever it is, then that, how does that work out?
You just contact me. My email was on the first page, and for example, this is Hi-Fi data, and for those of you that may not, Hi-Fi is, you know, doing this. They're building custom stations for height, depth, and stage for these very inexpensive stations. Now there's a bunch of them around Cleveland, but they have a bunch of them around Toledo and Erie, and I don't have the login information for that. There's not a security issue, but I don't have the code that, you know, identifies that set of stations. So suppose you were what city are you from? Sudhir?
So mostly grew around Cincinnati area, but right now I'm in California.
Oh, okay. Well, what I'm saying is if it's somebody from the Toledo area, there's all kinds of Hi-Fi stations in Toledo. I'm not getting that now because I mean, I could go ask for it, but, you know, we're pulling a lot of data. But if you find that you need data from Hi-Fi stations, or if you know there's data out there, and you want to get it, talk to me about it. I might know how to get it. I might be able to get it right now. In other words, we could start capturing this data immediately. All I need is to call up Brandon Wong at Hi-Fi and say, can I have the code for that? This guy wants to do this, and he's got a legitimate reason to look at it.
But essentially, you pull the data. Nobody posts data into your system.
You can, if you have data to post into it, like we can create web forms and post data into it, or if you want to post data into it, we can make that happen. But you know, that's all work. You know, it's all kind of like if you have a static data set you want to pull in, we have a really good toolkit to get that in pretty easily, but it's not. So if a tech team needs to have like some kind of static data in there, you know, we can look at helping to get that in, but that can be time consuming. So I can't make the commitment that we can do all that, you know.
So whose API do you find it easiest to pull data from, given all the systems you work with?
I really like, I think USGS has done a wonderful job with their APIs, but they're not easy, that easy. But I really like them. Hi-Fi did a good job. Actually, Gloss, the Gloss Seagull project, I look at their APIs and I think they're really well designed. So I think they're good too. And they're not public yet, but you know, I think when those become public, people will find them pretty easy to use.
And do you see them evolving to a standard of some sort on how this environment data pull API should be?
I don't think so, because I think a lot of the people that are designing the standards don't really understand real-time streaming data.
Yeah.
If I could be frank, you know, what I'm doing is basing this on a messaging or streaming data event model.
Yeah.
And if I went to a conference where they were talking about how should we pull or store environmental data, I don't think 90% of the people would understand that. And then they get caught up in this idea that we're exchanging research data. So now the data sets get ridiculously complicated.
Right.
And different from, you know, so I'd be happy to standardize. I've created my own standard because I don't think anybody's on board with a standard that will work. When they are, I will use it. In other words, if it turns out that Glosses really does a good job at this and they've kind of established a standard, I'll make it interoperable. I mean, I don't want to own the standard.